in Stata how to run a dual growth curve with time invariant covariates and the dual growth curve with time varying covariates. One of the things that I've noticed with Stata is that estimating longitudinal models like this, the more complex the models get, the more difficult they are to run and the more time they take. And so I've already run these models. They each took 3 or 4 or 5 minutes each to converge, and also I could not get them to converge using FIML with missing data, so you have a smaller sample. And I'm less familiar with Stata than I am with MPlus or AMOS, and so I'm not 100% sure that this is the best way to do it. That, you know, maybe because we have missing data, we know it, we're losing about half of the sample, maybe even 3/4 of the sample. We're going from 680 down to 250, and so that's not ideal. One of the options it gives you when you click estimate is to estimate using maximum likelihood estimation, maximum likelihood with missing values, which is the one I typically would use because we do have missing. And I really don't know what using the asymptotic distribution free method would actually do. And so I have not used that analysis. I've just used straight maximum likelihood for each of these 3 models. Okay, so for the first model we have wife, intercept and slope, husband, intercept and slope. The means for these show up in the diagram afterwards. For some reason they did not show up in the output here. Let's see. And the output I'm looking for this model is right here. These are all the different iterations that it went through. 250 is the number of observations in the end that it ends up with. And we have, actually this is the model with time invariant covariates. Looks like it's not, it actually has already gone off the screen, so because of the number of iterations. So just moving to the next model with time invariant covariates. We have income and number of children predicting intercepts and slopes. And for our output here, we have income and number of children predicting intercept of the wife, slope of the wife, intercept of the husband, slope of the husband. We have coefficients in this column here with a z-score here and a p-value here. And it looks like number of children and income predict the husband's marital quality, with higher being related to higher marital quality in each case. This is the growth curve constraints for the intercept and slope. And we have the variances, and we'd be interested in the variance for the wife's marital quality. Unfortunately, Stata won't give you a z-score or a p-value with the variances. So that Wald test is not performed within Stata. And then here's our covariances with a p-value. And those are as we would expect, intercepts being correlated and slopes being correlated. Next, we add time varying covariates. This gets a little messy. When it starts to look like a spaceship or a spider web, you know you're onto a good model. Here's wave 1 depression predicting wave 1 marital quality. Right there, wave 2 depression, wave 2 marital quality, and so forth up through wave 5 for wives. Then we have husbands predicting husband's marital quality at time 1, time 2, time 3, time 4, and time 5. We do have to correlate across waves here from husbands to wives depression because to account for the non-independence in their data. We also correlate between all predictors because they're essentially all exogenous, and so not correlating those would misspecify the model. And in this output, we see once again a number of iterations. Oops. Ending up again with 250 observations. And we have here our time varying predictors of depression to marital quality being significant. Wave 2, significant, wave 3, wave 4, wave 5, and then we have the husbands, wave 1, 2, 3, 4, 5. And pretty consistently we show a concurrent association between depression and marital quality, whereas when we go down to the intercept, actually we don't have depression predicting the intercept. These are, or the slope, they're just set up as time varying predictors. So these are not actually predicting the intercept and slope of the inner part of that model. And that's how you would set up a dual growth curve in Stata with time varying and time invariant predictors.